Hello, everybody. Welcome again to another wonderful episode. And in this episode, we are addressing a question by one of our subscribers that's by CodeNast, and he says, "Can we make a normal distribution from the time series to find out mean, variance, skew, etc.?" So what he's asking is if we can actually visualize the distribution of the data set first, and then also deduce some, regular statistics from them. Now, this is with regards to the time series episode, which was coding snippet 001, which is um, what we did in the very first session. The very first of this coding snippet series. And so to do that, we're going to maintain the regular imports we have, that's xarray, the numpy, and then also the matplotlib for plotting. We import our data and then, open the data set with xarray. And then also we do just a point selection of that data set. So we have this, that should be a time series. So if you remember from the very first video, if you haven't watched it, you can just go back and then watch it and you get up to date. But then it's something regular, something very easy to do. And so we have the time series in this form. And now we want to see the distribution of the data sets. There are packages already built to handle this. One of them is the Seaborn. So we can just import Seaborn as, say, SV. If you've not installed Seaborn yet, go to the PyPI, that's pypi.org page, and search for Seaborn. And I believe it should also be pip install, that should be the command line, pip install Seaborn. So with this, you can install. If you're working with your Spider, then it means in the command line, it should be preceded with an exclamation sign. And then once you're done, you should have Seaborn installed. So I have that already, so it works for me. Now, in order to visualize the distribution, we can just make use of Seaborn, which is what we call as SB. And then there's a package of it called the KDE plot, which is for a density plot. And we can just pass in our value, our data set to plot. So let's say SLS in this case. And this is enough to produce the distribution of the data. But then, for testing whether it's normally distributed or not, aside the pattern, we want to see if it varies between, the zeros and then the negative and positive standard deviation. So it means our mean should be a 0 mark, and then we should have negative standard deviations and positive standard deviations. So in order to change this data set, which ranges from about 22 to all the way 13 to that form, we just need to make use of the standardized anomaly. So let's define or build a function for standardized anomaly, say SAI, and pass in here whatever will be our dummy argument, say X. And all we are doing is to have X minus the mean of X. So we've imported numpy as np. We can type in np.nonmean of X. Now, I prefer to use nonmean because if they are missing data in the data set, which are replaced by say none, then with the nonmean, it would skip them and then would give us the actual mean. So let's say we have this A to be 1, 2, and then say np dot none, right? So this is our A. Now, if I type in A dot mean, or say just np dot mean of A, because this has missing values, it produces a none. But then if I type in np.nonmean of A, it's able to give us the average, taking out the none, all right? So that's it. And with the same approach, after placing this in a bigger parenthesis, we divide by the standard deviation. So we divide this by np.none std of the X. And that's all we are returning. And that should return the standardized anomaly values. All right, so in place of this, you are going to plot the SAI, which is a function of the SLS, not just the SLS alone. So we have a KDE plot of the SAI, that's the standardized anomaly index of the SLS. And that gives us the distribution with our 0 mark and then negative and positive standard deviations. Now, within the KDE plot, you can also include a shading. If you want a shade, you pass the shade function or the shade value to be true. So then it gets shaded for you, right? If you also don't want a bell-shaped form or this kind of plot, you can then pass in a cumulative and set the value to true. And this will then give us a cumulative plot instead. So if you want to see a cumulative distribution, then this will be the best approach to use. So by default, it is set to false. And then the default distribution used is a Gaussian. So the kernel set within the KDE is the Go, which is a Gaussian. And this is simply how to, visualize the distribution of the data set with the densities shown on the y-axis. You can also, change this and rather use a vertical layout. So vertical to be true. And then this then changes the orientation of the plot. All right, so depending on what you want to do, you're always at liberty to do that. All right. Now, in order to find the statistics, there's also another package which is already from SciPy. So you can just import from SciPy. We import the stats. All right. And with stats, you're able to find various statistics of the data set. So if I have pass in here stats, say dot kurtosis of my SLS, it gives me the kurtosis value. If I pass in stats.say skew of the SLS, it gives me the skew value telling me it's skewed whether to the left tail or to the right tail. And you also, there are a whole lot of things you can actually do. So for instance, the variance. And for the mean, you can actually just use the numpy and then you're done. So just pass in, let's say your np.nonmean of x and that, sorry, I mean of your SLS, which is the data we are using, and you get the mean, all right? If you want the mean of the standardized values, then it means you pass in the SAI as a standardized anomaly index of the SLS, and that gives us the mean value, all right? The same if you want the variance, I think in stats there should be a variance. Okay, if it doesn't, you can just try the mstats. Under mstats, I believe there should be a variance. Okay, we are not getting anything like that. Well, but in simple terms, the variance is just the square of the standard deviation. So if I just pass in, let's say np dot, and try var, yeah, np dot var should even give me the variance here. So np dot var of x, sorry, I mean SLS should give me the, okay, sorry. Let's try this, np dot non-std of the SLS. Okay, that gives us a standard deviation. So we can then raise this to the power 2, and that should give us the variance. So, I mean, just simply understanding what to do comes in very handy. Now, you can also pass this as a whole function to generate all of them for you, but then wouldn't delve into that in this video, just to keep it very brief and then for your consumption. So that's simply how to generate your distribution plot using the Seaborn package. And I believe you enjoyed this episode. I mean, if there's any question, you can always ask, and then the team here would address it. If you're new here, don't forget to hit the subscribe button, hit the bell notification, then be notified whenever there's something new we put up here. I pray you have a wonderful, Python journey. Enjoy the ride as we go on and keep learning and keep achieving. Have a wonderful time and see you in the next episode. Bye-bye.